I'm Alicia. I'm from Texas, and my research project was over spontaneous speech and gesture coordination in bilingual STEM instruction with my mentor, Bianca Barajas, um, who from the University of California, Merced. So let's start with why gestures matter in STEM classrooms. So what we've been seeing is that across US classrooms, bilingual and dual language programs are rapidly expanding. In this graph that I adapted from America the Bilingual, which is like an online post, we can see that there's been a massive spike in these dual language programs. So along with that, teachers have to face an additional challenge of building subject knowledge while also supporting the language development for this other language, which is often Spanish. So using gestures is a good multimodal teaching tool that can help enhance comprehension, support memory, and facilitate learning. So often early on in grade school, teachers introduce different gestures to help not only with like classroom instruction, but also other things. So this is like an example of classroom hand signals that maybe you would see in an elementary or intermediate school, where students or the teacher can make specific symbols with their hands to indicate something like that they agree with the point, they have a comment on something, or perhaps they need to go to the bathroom. And it reduces a lot of confusion and makes the lesson more interactive. So one example of a gesture here that a teacher could be using, and this is something that we wanted to look into, was creating AI generated videos to help depict different gestures. So we generated this with Google Veo from which uses like Google's AI technology. And a lot of the videos we tried were actually not very great at representing what we wanted them to. But in this example, this is actually what we would call an iconic and supplemental gesture, which we'll look at a lot later. So our project direction, we had two main research questions, which is the first is how do bilingual STEM teachers coordinate speech and gesture during instruction? And the second one is do teachers' gestures differ depending on the language of instruction, either English or Spanish, or the content area, which is science or math? So our hypothesis based on prior work, we believe that science instruction often involves procedural demonstration that invites the use of more iconic gesture, whereas mathematics instruction frequently involves abstract reasoning, which may lead to teachers using more didactic and metaphoric gestures instead. So there's a bit of a difference there. For methodology, we analyzed 4 classroom recordings, which are just recordings of teachers giving lessons in their classroom environment. So this was across the 2 subjects, math and science, and the 2 languages, English and Spanish, with 1 teacher for each of the conditions. So undergraduate students already coded these videos to depict which timestamps had which kind of gestures or other modifiers. And the way that they coded this was based on first our biliteracy codebook, gesture observation, protocol, and education, which is a method that my mentor is working on developing, and the English Learner Instructional Strategy rubric. So what they looked for specifically were different gesture types. There's a lot more specific things in here, but the main categories were iconic, which are gestures that depict actions and objects, metaphoric, which represents abstract ideas, didactic, which are like pointing gestures, beat, which are more rhythmic movements that are used for emphasis, and emblematic, which are different cultural symbols and signals that we as a society we already have like a meaning for them, such as the thumbs up, or maybe I know in some schools like if you cross your fingers, this means that you need to use the bathroom. The other thing we were looking for are modifiers. The modifiers are looking at how the gesture interacts with the language of instruction. So what that means is, for example, the redundant modifier only applies when the gesture is some type of representational gesture. And so that means that our gesture can either repeat information that is being expressed verbally or add new meaning beyond the speech, which would be supplemental. So in the video from earlier, she said that there's two main parts of the sentence and she holds up a two. So this is repeating information that she's giving verbally, perhaps for emphasis. And so we have emphasis, which highlights or stresses verbal content, and recall, which prompts students to remember. And these are both forms of the beat gesture, which, as we looked at earlier, is also used for more emphasis. And then the other modifiers we have are open and closed, which just indicates open or closed questions when the teacher is questioning, right? And yeah, I think. So to do our analysis here, we looked at three different approaches. So the first one, we're looking at the transitions in between our different gestures and behaviors. So here we made a bunch of transition probability matrices to determine the likelihood of a gesture coming after a previous gesture. So we just computed like conditional probability. So the probability of something happened given that this gesture is happening, right? And then the next one we're looking at is correlation analysis. So we did correlation analysis for both the behaviors and for the modifiers. So we calculated these Pearson correlations between the gesture behavior frequencies and the instructional conditions. Um, so what this means is that we're associating specific behaviors more so with certain things like English and Spanish rather than math and English. Wait, sorry. Something like math taught in Spanish, maybe there's a specific gesture that they do more frequently than something else like English instruction in science, right? And all of our analysis was conducted in like Python. So here are the results. It may seem a little intimidating, but we'll break them down. These are the transition matrices. So let's first take a look at specifically the math instruction. So we have our two languages here, English and Spanish, and we're kind of looking at some of the how the behaviors and gestures follow one another within each observational conditions. So if we look at our key transition probability, just the darker colors are less likely and the brighter colors are much more likely to occur. So we notice that there are some consistently darker areas, such as this diagonal, which makes sense because this is where our behaviors are like self-repeating. So as we can see on the axes, we have all of the behaviors listed out. So this middle diagonal is just showing where we're looking at the overlap between two of the same behaviors. So that would always have a probability of 0 because in coding that, it would just be recorded as one continuous um, time stamp rather than two subsequent timestamp. So these darker lines also show maybe where the gesture was just a lot less prevalent in our videos. So specifically, we can look at some of the brighter spots which have a higher probability of happening. So we see that there's a good likelihood that the teacher will transfer from an echo behavior to a mirror behavior. And some other things to note, maybe from writing to emblem, from small group work to individual work, which also I think makes sense. And then in the Spanish section, we can also see a little bit of a different pattern, right? So from materials to behavior, so maybe from explaining materials to explaining the behavioral expectations. From individual to no language, what might indicate that they're being very quiet during their individual work. From cueing to pointing, or from explanation to questions, which also makes sense. Inviting questions after explaining things. So now we also have our science instruction. So again, the two languages, English and math, some things that we could note here. We're demonstrating repeated transitions between things like mirroring and pointing. So mirroring and pointing behaviors, feedback and no gestures. So maybe after giving feedback, the teacher will pause for a little bit to help the students comprehend the feedback that was given, and from beat to representational gestures. And then in the Spanish, we identified like transition again from materials to behaviors, which we also saw previously in the Spanish and math instruction. Similarly, from question to materials, and from individual to no language, which again maybe indicates silent independent work. So overall, this is from all of the math from both science and English, and this is from both of the Spanish and English instruction for science. Just to examine some differences in between the two subject matters. We do, however, see that there are some very similar, very common transitions, especially from our beat to representational, pointing to emblems, individual to no language, as well as going from maybe some inaudible to whole group, which also might make sense because it might be a little chaotic organizing everyone into a big group. So our other approach, we're looking at the correlation pattern. So again, with this, it's every row should add up to a total correlation of 100%. It's just saying that maybe for mirroring behaviors specifically, it's much more associated with the math English subject rather than the other three categories. So the math English group shows several demonstrative or echo codes with strong positive associations with echo, mirror, or cueing as hotspots, whereas math Spanish has strong positive clusters on framing or absence markers and these more group-related activities. Science and English group suggests that concept-forward teaching behaviors, such as communicating objectives, asking questions, and giving feedback, are more consistent with the teacher-led explanation and guided question during science demonstrations, especially with positive clusters for academic conversation, explanation, description, materials, and scaffolding. And then science and Spanish had a lot fewer of the extreme correlations, except for here with joint and emblems, showing very consistent with culturally conventional signals that might pair well with Spanish instruction. So now we're looking at modifiers. Again, modifiers are showing how our gestures interact with the verbal instruction from the teacher. So we have our modifiers over here. And in math and English, we detect strong positive correlations for open and closed questioning. So questioning strategies were probably closely tied to English-based math instruction, suggesting that maybe the teacher relied heavily on both open and closed-ended questions to guide student reasonings and to check for understanding along with their gestures. So there's also a very nice positive correlation with supplemental that reflects the use of gestures that add context beyond the verbal instruction, which probably helps make these abstract mathematical concepts more tangible. And then there is an extreme high positive with recall. So maybe there's a lot more that the teacher is prompting the students to remember for this math subject. So overall, what we can notice is that science instruction consistently elicits more representational gestures, such as iconic and metaphoric, if we're looking at the different categories here, whereas math instruction is tied to more like pointing and uh, more pointing gestures. So language also matters because it relies more, Spanish overall was relying more on pointing, which is didactic, to anchor maybe new words to the visuals that they have that helps you understand language better, while our English lessons are more on metaphoric explanations because maybe the students already understand English to a good degree. Right. So yeah, once again, math is more didactic and metaphoric, and science is more iconic and representational. Spanish has more pointing and redundant gestures to support vocabulary because maybe our students don't know what the Spanish words mean, but the gestures can help them figure it out. And English lessons are more metaphoric and have hybrid gestures. So in the future, we're considering work using deep learning and for automated gesture recognition and more AI generated simulations, such as the one we saw at the beginning, to help support teacher training and encourage the use of meaningful gestures to aid in student comprehension, as well as finding larger sample sizes. So this can mean more classrooms, more teachers, or just more lessons recorded by those 4 teachers that we've already selected. So yeah, I just wanted to thank the Talaria Summer Institute. I'm very grateful for these past 6 weeks with my fellow mentees and my wonderful mentor, Bianca. Thank you again for this great summer opportunity. And I'm sorry, I think I went a bit long, but yeah, thank you so much.